In this video, I'm gonna go over the basics of how to set up a flip simulation in Houdini and do a quick render in Redshift. This video has a second part to it, explaining how to set up a flip sim in a more complex scene. The second video will explain how to configure the flip simulation for water collisions with a high poly geometry as the environment. So the current video you're watching is only intended for beginners. If you have some experience with the flip sim already, please check out my second video, which will be more useful to you. I'm going to post a link in the description below. I first intended to make one video, but it ended up way too long and there was a lot more I wanted to cover, so I split it into two videos instead. Here's a brief overview of the topics for this video. I'll start off with a bare bones setup of a flip sim. Then I'll explain the different setups when you need infinite water emission like a faucet. Next, I'll show you what happens when you combine both. Last, I'll do a very simple render just to show you how to render the water after the simulation is complete. The render will be a very basic one and is meant to only start you off in a complete workflow so you know the basics from beginning to end. I'm not going to be going over how the materials are set up and just simply use one of the built-in materials that come with Redshift. I'm going to start off with a simple example. We need an emitter. So this tells the software where the water is going to come from for our flip sim. So I'm going to use a cube. Then I'm going to raise the cube a little bit above the ground. Then I'm going to drop down a null. It's always a good practice to have a null at the end. I'll call this emitter. Now we're going to start on the simulation. So I'm going to call this the flip sim. We need a .net. So let's go right into it. Now to bring that emitter into the .net, we need a flip source, a flip object. So it comes with the default cube. Now this is not the cube that I created. This, if you remember correctly, I made the cube above the ground a little bit, so this is right on the origin point. So this is not the one that I created, it's the default one that came with it. For the stop path, this is where we choose that emitter cube that I created at the beginning. So you see here, you can choose the emitter right here. I can choose it like this. However, I want to be a little more organized, so I'm going to drop down an object merge. So I'm going to bring that emitter cube into this node context first. So this is the cube I created. Now I'm going to drop down another null. Now we're going to go back to the .net. Now we're going to choose the one that we brought in. So I'm not going to use this context level. I'm going to use this one. In the flip sim node, the out emitter cube that we dropped the object merge. So this is just a little bit more organized. I mean, you can choose this one. It makes no real difference. It's a little more organized this way. And when you get more complex scenes, you'll find it a lot easier to manage your projects. So this is the actual cube brought into this flip sim. It's raised above the ground a little bit. So we just play the sim, nothing will happen. Let's drop down now. Every sim needs a solver. So let's drop down the flip solver. Let's play it again. Still nothing happening. This is because there's no forces acting on it, and there's nothing to collide with it. There's absolutely nothing to do in the sim, and nothing to do for the flip solver to calculate. So let's give it some gravity. The water falls, but it doesn't do anything interesting because there's nothing to collide with it. So let's give it a ground. Now when you're adding another static object, it's a good idea to have it merge with your existing solver setup. And you always have to merge it from left to right. So you can see here this is crisscrossed. So you don't want that. You want to raise the ground plane above so it goes left to right. Now let's give it a try again. We finally see something happening. It's the water is colliding with the ground. So this is a very simple simulation. We have a fixed volume of water and it collides with the ground. Now what if we wanted flows an infinite amount of water, like a faucet, so it just keeps flowing water out? Let's go back up here. Let's go here. Now I'm gonna reuse this box, but I'm gonna move it over a bit. Okay, after I moved the cube over a bit, I'm gonna drop down another null. I'm gonna call this cube 2. So I'm gonna change this name as well. Cube 1. Let's go back to our flip sim. Now I'm going to make a copy of this. Drop down another null. So I'm just going to change this to cube 2. This is the one that we moved to the right a little bit, and this one was the original one that we raised above the ground. Let's go back into our .NET. Now we're trying to create a sim that has water constantly flowing out of the second cube that we created. In order to do that, we need something that's called a volume source. The volume source will emit water infinitely into the sim, like a running faucet. So we're going to hook this up to the last spot here, last input of the flip solver. Now, for the volume source input, you can choose the node specifically. So I can go here, go to the flip sim, and choose the second cube emitter. Or you can choose it from the first, second, third, fourth contacts. So what these 1, 2, 3, 4, what those are is the first input of the .NET, the second input of the .NET, third, and the fourth. So we can take the second cube and we can feed it into the first input of the .NET. And that would be the input first context geometry. Let's go back to the flip object. Let's take this out. Remember we had this at the beginning. Let's take that out because we don't need it anymore. Or that's not what we want. Now let's try it again. Let's replay the sim again and let's try it. Nothing happens. Absolutely nothing happens. So this is not working. Now this requires a volume source. Our emitter, our second cube emitter, that wasn't a volume. If we go into it, this is a polygon. So there's something called a flip source. So this turns it into a surface volume. Let's just compare this. I'm going to take the cube and I'm just going to compare what happens after you put down a flip source. You start off with 8 points. So this is a polygon. This is just a regular cube. Then it turns it into a surface volume with 3,332 voxels. Volume is made up of voxels. Polygon is made up of points. The more voxels you have in a volume, the greater the detail, which is similar to polygons. The more points you have, the greater the detail of the mesh. So let's go back to the flip sim. Now we actually have a volume feeded in. So let's replay the sim. Still, nothing happens. Now, we have it hooked up correctly. We have a volume coming in. What could be it? Here, it says initialize source smoke. Well, that's not what I'm trying to do. I'm trying to source it as a flip. Let's change it over here. Now it creates the density out of the surface volume. If you remember correctly, in the second cube emitter, we have the surface volume. So let's go back to the flip sim. So it takes this surface and it converts it into density, which the flip solver needs to calculate the simulation. It tells it how much density of water is flowing out of this cube. So let's try it one more time. So we finally have something. Water flowing constantly out of the cube. So say we want both a splash of water and constant flowing water in the simulation. So in the flip object, let's add that back in. Let's add our first cube back in, which is this guy. And let's play the sim. So now we got our splash of water on the left and our constantly flowing fluid on the right. You can have like a mix of both. So you can use this way to have finite water here in using the flip object and a infinite flowing source of water in the volume source. Now you might ask, if we only need the faucet running, like a constantly flowing sim, why would we need the flip object if like our scene doesn't require a splash of water? So all we want is this. Why can't we just delete the flip object completely? Now let's try disconnecting this. It gives us an error here. This flip object is necessary input for here. What the flip object does, it instantiates the water in the simulation. It takes in the flip object, it takes these values, these properties, and assigns it to the water. Whether it's sourcing it from this volume source, or maybe it starts off with that splash of water that we specify here. Whether it's either case, it will take all these values and assign it to the water. So this is actually necessary. The flip object is necessary in the simulation, whether you're using that splash of water at the beginning or not. This can be empty if you don't have that splash of water. But this object here must be present and connected to the flip solver. Now we're gonna talk a little about rendering, just so you have something working from beginning to end. Let's go back up to this level. Now we don't need to render the emitter. because the fluid is coming from the flip sim. Unless you want to render the emitter, then you can, but I'm not going to for this. Now we need a camera. And I'm just going to drop down a dome light. Go to the out. I need the redshift. Now I usually like to turn the progressive rendering off so it just loads everything as fast as possible. Let's go here. I'm going to turn the camera a little lower quality resolution so it can render a little faster. Now nothing comes out. This let's just keep it rendering. This sim. Okay, I'm just gonna move this over. So in order to render or use the data for the .NET, we need a .import. So what the .import does, it grabs all the data from this .NET simulation and it brings it up into this context so we can use. So the .import is asking us what simulation, where's the .NET. So we can just click the .NET and drag it over here. Import style, I want to fetch geometry from .network. Turn the flag over here. Now still nothing is rendering. That's fine. I'm going to take a look at the geometry spreadsheet. We have a lot of points for this .import. If we take a look at what the .NET looks like, it doesn't have that geometry spreadsheet data that we're used to seeing. It has all these objects and all these different nodes. It has a very different format of data. So what the .import does, it brings all the simulation data and puts it up a level into the format that we are more used to, this geometry attribute table that we're used to seeing. So if I click on the cube, what we're really used to seeing out of geometry, we have all these data, we have all these attributes. So that's what the .NET does. It brings the simulation data up a level. But we still can't render. Nothing's coming up. But we know we have points. I can see that there are points. So for the simulation data, I'm going to go to Redshift object. I'm going to go to particles and I'm going to enable it. Ah, we see something. But that's not water. That looks nothing like water. It looks like dots. You can even see the ground, the dots on the ground plane as well. So that's not what we want. But this is just to confirm that it's working, that we have something. It's just that our setup isn't allowing us to render it properly. So let's turn that off. And refresh this a bit. Okay. Now there's also something called particle fluid surface that will take these particles in the .import and turn it into something that looks like fluid. So it's not very clear, but it looks like we're getting something that looks like fluid here. So it turns the .import, uses all that attribute data and makes it into a geometry. This is actual geometry that we can actually see. It's almost like I need a material. Now we don't have a material to work with, so let's create one very quickly. I'm gonna go to the shop. Now the reason why I'm using the shop context is because when I go like this and go look for the Redshift material, the default material, it gives me a smaller list, as opposed to over here. When I go Redshift, there's a lot of stuff here. It's just easier to click. There's no difference in, like, I could just go like here and search for the here. I could just do this and choose water and do it like this, but it's just easier to film when you're going like this. It's a shorter list, so it's more clear. You can use the material context if you wish. Choose water. Let's name this water material. Water. I'm going to color this a bit. So, I don't know. Maybe light blue. Sure. Let's go back to our object. Material. I'm going to choose that water material. Now it looks, we're seeing something here. So this is, don't forget that null. It's a very good practice to have the null at the end. Here's the result of the animation rendered out. Thanks for watching this video. If you're interested in building on top of this sim, there's a second part to this video that demonstrates how to use the exact same sim setup shown in this video and change it so water collides with the more high poly mesh instead of the simple ground plane. Check out the description for links.